Um, okay. Good afternoon, everyone, and thank you very much for being here with us. This is the fifth and last webinar of a series of webinars. My name is Andre Arsenio, and this time around I will be chairing this webinar alone, since we will be doing this in English. This time there will be no simultaneous translation, which means that the slides will be in English and the presentations will also be in English. We'll have 3 presentations all in a row, and at the end we'll have a Q&A session, and you can ask your questions, so that you can ask your questions via the chat. We will write these down and then we'll ask the questions at the end. We are here today because Aquashare Association, a Mozambican knowledge association in partnership with Technical University of Delft, is implementing a project entitled Supporting Integrated Water Approaches for Urbanizing Maputo through Capacity Building and Advocacy Activities. This project was dedicated to promoting, or is dedicated to promoting and empowering themes related to the concept of urban water cycle and integrated urban water management. The project integrates themes on the, the project includes themes on water reuse, aquifer recharge, and other topics. This is sequential to a first project that supported Mozambican doctoral students with a thesis on Mozambique, which is funded by the Dutch Research Council, the NWO. The project was initially conceived to be implemented through national and international seminars involving experts in the field, but due to the COVID-19 pandemic, we reformulated it and the seminars were replaced by webinars. As I said already, this is the last of 5 webinars that we had, which included the urban water cycle, water reclamation, governance, a managed aquifer recharge, and now a series of case studies. Here today with us, we have 3 renowned speakers who will lend us the best in this area, and they will share with us lots of hands-on experience with water reuse projects from across the continent. This includes examples from Etiquini Water and Sanitation in Durban, South Africa, which is a very interesting project on water use for industries. Namibia, with a very famous direct water reuse project that has been in place for already a few decades. And then finally, Mr. Faisal will tell us about the challenges and experiences with water reuse for irrigation in Northern Africa. So I call your attention to dive into the sea of knowledge that is coming, and thank you very much for your attention. Next slide, Noor, please. So to start with, we'll have, as I said already, Mr. Pierre van Rensburg. Mr. Pierre is the head of urban and transport planning at the city of Windhoek in Namibia. As a born Namibian, he is passionate about the infrastructure development in this country that will ensure economic prosperity to all residents. Pierre, thank you very much for accepting to be here today, and please share your screen. And tell us all about the project. Just to remind you that you are muted and your camera is also off.
Okay. Andre, can you hear me?
Yes, I can.
And you can also see the screen?
Yes, it's all good. Thank you very much.
Okay. Thank you very much for the introduction, Andre. From my side, I think thank you for being allowed to be part of your initiative. It's really great to meet up with the other people and also to be able to share some of the experience we've had in Windhoek. The presentation is a little bit long, so I'll be quickly going over some of the slides, but just for the participants, if they want to make a note and at the end we can come back, it's not a problem for me. I've put the logo, you see the 50th anniversary logo on there. As you've mentioned, Andre, this is not something new in Namibia. So what I'll try and do is to give you sort of an overview over the project over the lifespan, but particularly covering the items. Okay, there we go. Particularly cover the items as to where and how did the DPR originate as an idea so early on, already in the 1960s. What was the process that was followed at the time? And then a little bit about public acceptance. I'll also touch on the funding issues or financial issues, and then just give you an overview as to how this project is assisting us in similar situations to what I just heard you discuss with the gentleman from Maputo. So without further ado, as I realize not everybody might be familiar with Namibia as a country, I've just got some slides to quickly put it into context. If you look at the deserts in the world, and particularly in Africa, you note the Sahara Desert as the dominant desert in the north, and I'm sure we'll hear about that later. But if you go to the southern parts of Africa, and specifically the southwestern parts of Africa, you find two deserts, the Kalahari and the Namib Desert. And interesting enough, those two deserts actually make up the majority of the land, the surface of Namibia. So moving on, if you look at surface water, it's not surprising to see that despite the fact that Central Africa and much of East Africa is fraught with surface water, if you move to the west, you will find that Namibia is a nice blank spot there with literally no perennial rivers inside its borders. And if you zoom in a little bit more and you go to the city of Windhoek, which is actually sort of in the middle of the country there, you find it's at the furthest possible spot that you could be from any available surface water. So you have the Kunene River in the north there on the border with Angola, the Okavango River there shared between Namibia, Angola, and Zambia, and then some other rivers further, Zambia, and then you have the Orange River in the south, which is shared with South Africa. So that's just to put it a little bit into context. So water supply in Namibia and Windhoek particularly is very, very challenging. So if we then go back in history and to see, why did they consider direct potable reuse at the stage that they did, this kind of should tell you the story. It's called the post-World War II population explosion. But if I can put this in very simple terms, the population of Windhoek went on sort of almost flatline, slowly growing, until you see the year there is 1946, 45, 46. It really started to rapidly expanding, and it was because of the establishment of a lot of government services in Windhoek and the decision to make it the administrative capital of the then Southwest Africa. So as you can see, that led to an immense population growth, and soon they ran out of water sources. So by 1957, there was a period where they had to actually practice water rationing. Insofar as we know, it was the only period ever that the capital city ran out of water and they had to actually ration the people. But that led to a crisis which was then taken up in the government levels. And as it is usually the case, the government established a commission, what they call the Executive Commission, to look into it. And their job was pretty simple. They had to see, what is the demand at the moment and the foreseeable future, review the available sources, and then investigate what additional sources they could bring online to solve the problem. And then obviously, as all government reports, it ends with how much will that cost. So if you look at the situation then, they had about 35,000 people and they needed about 4 million cubic meters per annum. And what they had were three sources. They had two smallish dams. If you look at the capacity there, 2.4 and 3.6. Very small dams. The Korangap Dam was just completed, brand new in 1959. But the majority of the water was coming from the Windhoek Aquifer, from boreholes that they have drilled. So if you look at the yield of the dams there, it's 0.4 million, and the Korangap Dam giving you 0.8 to 1 million. So that gives you 1.4. What you needed was 3.8. So the surplus or the bulk of that came from the Windhoek Aquifer. even though the safe yield at that stage was estimated to be about 1.6 million cubic meters. So they were massively overdrawing on the Windhoek aquifer already at that stage. So they looked at a number of options, and this is what the Executive Commission actually presented. And they also made recognition of the facts that the boreholes were already sorely overtaxed. That's a quote from the Executive Commission findings report. So you can see water loss control, obviously quite an obvious one. They tried to maximize the use of the Avis Dam, and the reason for that, I guess, was the fact that the dam is upstream of the town, so they could gravitate water from there. They were proposing an additional dam downstream of the Goriangap Dam, which is called the Gammons 3 Dam scheme. And then they proposed the Swakop Dam, which is would have been then a state supply scheme some 70 kilometers north of Windhoek. And the last but not the least, and it's an option that was proposed by the City Council of Windhoek to say, but we are fairly confident that we can actually reuse treated sewage water and supply up to a third of the potable demand of the city. This option was new to the government at that time, but the municipality had been working on it since the sort of early to mid 50s, 1950s, and they were convinced that it's a technically feasible option. So that option was in the end included, although maybe a little bit against the wishes of the government. But in the end, it came down to the economy. They looked at the options of building the dams, both the Gammons 3 Dam scheme as well as the Swakop Dam scheme. And the council actually did quite a comprehensive economical analysis on that. And the conclusion was that they don't have enough people, enough demand centers to actually justify the cost of those bigger state schemes. And they needed some time to build a bigger population, that they have more users online to be able to recoup that cost. So in the end, it was based on economics of the situation, and the decision was to try and pursue the reuse as an option. So just a quote again on top there, it can be readily seen that the reuse of water from the sewage works is the key to the whole report. Every effort should be made to ensure the supply from that source. So it was agreed then in 1960, towards the end of 1960, that they would pursue direct potable reuse. So just some comments on the early days. They then incorporated the Council for Scientific and Industrial Research, the CSIR in South Africa. They had them under contract in the early days to try and develop the scheme. So they signed up a new contract with a more focused approach. They did extensive pilot studies both here and in South Africa between 1962 to 1965. And that then led to the design of the first full-scale plants for about 5,000 cubic meters per day, or 1.6 million cubic meters per annum. So what they did in essence was, if you look at the picture on the right-hand side, that's the Goriangap Dam at the back. They basically converted the old water treatment plant that was built for the dam into a reuse plant. So the wastewater treatment plant is just situated next to the dam to feed into the plant, and they had the option of taking some water from the dam as well as water from the wastewater treatment plant into the reuse plant. So production then started already in October 1968, and as you can see there, it was just in time for another dry spell, because within the first year they managed to produce a quarter of the total supply to the town from this reuse plant. The Swakop Dam scheme, interesting, was then only completed and started producing water about 15 years later, 16 years later. So that this really gave them the time to complete that bigger capital project, and also to justify the cost in terms of the number of users. The other interesting fact is that the Gammons 3 Dam scheme, which was actually the primary proposal from the government side, was never built. Even up to this day, that was never built. Just some comments on the early days of DPR in Windhoek. Interesting enough, the government was very hesitant to actually declare the Windhoek DPR plant as call it a normal supply source. So it was only declassified as a research facility in 1982, which was 14 years after the initial supply started. They did keep the testing facility, which was in Pretoria, South Africa. It was called the Stander plant. And during the first life of the Windhoek plant, they kept on doing tests and improvements at the Stander plant, which after testing was then implemented in Windhoek as permanent solutions. Also during that time, interesting to note, it shows also maybe the distrust in the solution. 4 different independent laboratories, 2 in Namibia and 2 in South Africa, was involved in monitoring the effluent from the plant to ensure compliance with the set standards. So moving on, then just as I said, the standard plant was kept in the early days. So here you can see actually all the various upgrades to the plant. Obviously, if you have to build the plant today, you wouldn't build the plant. It was built in 1968. But you can see it's called Mark 1, 2, 3, 4. So at the moment, we are at sort of the 6th version of the plant in terms of technology. And here you can see the additions and how the plant evolved over time. Just some pictures on the left. You can see this is what the initial plant looked like. You can see that it was, yeah, you can kind of see that it's what is the right word? They adjusted the old plant to meet the DPR requirements. And on the right-hand side, you see the purpose-built new plant, which is not so new anymore. It's about 20 years old at the moment. But this is what it looks like, and obviously more modern with the centralized automated control and obviously including membranes and so forth, which was technology not available in the 1960s. Just quickly on the process train, I don't know how many of the participants are technically inclined, but I'll just quickly run through the process. So what you have is raw water blending. As I said, there were the 2 sources from the Goreangab Dam and the sewage treatment plant. The Goreangab Dam in the last 20 years of the new plant was almost never used. So we use almost exclusively, not almost, for the last at least 18 years, we have been using exclusively treated sewage water. So the first step is a pre-ozonation, just to destabilize some of the organic material. And then also the introduction of ferric chloride, which is the main contributor to the next step of dissolved air flotation. After dissolved air flotation, there's a chemical stabilization for the pH, followed by normal sand filtration. After the sand filtration is really the main chemical treatment step, which is ozonation. After ozonation, there's a removal of the residual ozone just because you are followed by a biological step. So you have a BAC, biological carbon filtration, followed by GAC, granular activated carbon. And then the last step, which is the ultrafiltration in the membranes, and then just normal water stabilization before supply to the town's residents. Just some principles. I just want to spend some few moments here. The first principle, and I would say the fundamental basis of the DPR in Windhoek, is that we only use wastewater from domestic origin. So in the town, actually the drainage areas for industrial and domestic has been separated with industrial draining to a separate plant. And the water that goes to the plant that supplies the DPR option is just purely domestic. Then the monitoring is quite important. We call it whole cycle monitoring. It basically means that you monitor the whole cycle from the point of discharge, where somebody discharges wastewater into the sewer, back again to the point where you supply to that same site the treated water. And you have to be able to know what's happening in that entire cycle in order for you to really control the process. Effective biological treatment, it means that your wastewater treatment has to be up to standard, because that a consistent supply from there in terms of water quality is very important for the reuse process. The multiple barrier treatment, I think, is well known in the DPR world today. It's just that there is more than one process that actually takes care of a specifically identified contaminant. Blending of the final effluent, that is something that is brought about due to the fact that we use direct pipe-to-pipe reuse. So in an indirect process, you would have blended back into a natural source or back into a river where there would have been some dilution. Because we are not doing that, we are taking a 1/3 to 2/3 proportional dilution from surface water, from rainwater from the surface water dams. So that's also quite an important cornerstone of the process. And then last but not the least is ongoing education and communication to the users. People need to know what you are doing, and they need to have trust in what you are doing. So you don't just win the trust once off. So that leads us to sort of the public acceptance. So how was it that people were accepting the fact that they were drinking their own treated sewage? So at the time, or around about the same time, you see the newspaper clipping on the right here is from 1968. It's November 24, if I read the date correctly there. Around about the same time, the first heart transplant was done by a surgeon from South Africa, from Cape Town, if I'm correct. So the mayor actually went on public record and saying that this is such an achievement, and it was actually talked up as an achievement and not something that was done out of need. This is such an achievement that he actually put it equal to that first heart transplant being from the same region. And at the media conference, he was standing with a glass of water at the plant with the reporters. And when he was asked why he keeps on referring to the glass, but they haven't seen him actually drink from the glass, all he said was, as a good politician would, to be honest with you, I already had my glass. But he also mentioned the fact that they had a testing panel where they had people testing the water, and one of the samples that was up for the testing was from the reuse plant, and he said that 3/4 of the people actually preferred the treated sewage as the better water or the better tasting water. So now I don't know if that's true, but that was one of the motivations that he gave in his speech. But the interesting fact is that although they already started supplying the public from October, they only really informed them on the 22nd of November, more than a month later. So if you look at the chief scientist report from about the same time, I think it's about a week later, it says we did not reveal too much. This is now referring to the media conference. And generally the news was accepted calmly, hence the public's accepting the development nicely. So you can see at that time, public acceptance obviously wasn't handled in the way it needed to be done today. But I think if you look across the world, there's been many towns and cities that actually want to introduce DPR, and they have come up with some really magnificent ways of introducing it to the public. I can think of San Diego. I've got some material on that, so if anyone is interested, you are welcome to contact me afterwards. But this is how it was done in Windhoek. Then just interesting what happened in between. So the initial decision, I would say, was pushed through just because of a lack of alternatives. There wasn't really anything else that they could do at the time that was economically viable and it could supply them the amount of water that they needed. But when the next drought came around, which is quite frequent in our part of the world, the residents actually criticized the town council for the fact that there was remaining effluent running away from the plant downstream that they felt could have been reused. So that led to a decision at the time by the council to upgrade the plant by about 50% from the initial 4.8 to 7.2 million cubic meters per day. And the same thing happened in the 96-97 drought. Similar public sentiments and petitions actually led to the plant being doubled in capacity to supply at that time and to continue supply. This is just a study we did a few years back. It just shows you how much the public know. So the questions that were asked are sort of top to bottom there to say, do you think the water that you drink is good enough to drink? Does it meet potable standard? And the majority said yes. Then it said, but despite it tasting okay and look, aesthetically looking okay, do you believe that it's safe? There's nothing in the water that you perhaps cannot see, but that could harm you. So it dropped a little bit from 85 to 79, but still the majority of the people felt that it was safe. But then if you ask them if they knew that a third of their water actually comes from treated sewage water, it dropped to 50%. So this actually shows you that continuous public education is necessary, because people might know about it during a time of drought or during a time when the solution is introduced, but many years later, people actually don't know. And the study found that people who had a residency of 11 years or more at that time kind of knew about the source of the water, but younger people and people that haven't gone through a drought, because 11 years was the time to the last drought, don't actually know. So just some financial considerations. I don't know how I'm doing on time. I'm trying to stick to the time limits. But just on the left-hand side, you see
have 4
capital costs.
minutes.
So, okay, now I'm nearly done. So on the left-hand side, the construction cost in the year 2000 was approximately 18 million US dollar. And that was for a fully automated plant that could treat 21,000 cubic meters per day, or about 7.5 million cubic meters per annum. We are busy with what is called DPR2. So we are planning a new plant to be completed in the next 4 or 5 years. And we're only at the pre-feasibility stage now, but we have done cost estimates based on what they did in Cape Town, because Cape Town is also currently looking at DPR options. And the indications are that you're currently looking at just under $2 million per megaliter. So just to give you an indication of what current cost would be. The OPEX, I took the operational cost of last year, the year 2020, and that was just under 5 million. And that translated into about 90 US dollar cents per cubic meter. That's the price that was at which the water was sold to the public. And this cost obviously includes consumables, maintenance. There's quite a bit of reinvestment in the membranes, which have to be replaced in total, I think once every 7 years contractually. And then also it includes quite a lot of money that's going towards monitoring and research, because this plant, even though it's 20 years old, we are doing continuous research, because the world of science is evolving, and what people can measure becomes more and more, and also the level at which people can measure it. So before it was okay if something was below 1 milligram per liter, but now you're looking at nanograms per liter, etc. So we have to continuously kind of make sure that the plant meets all the new standards and all the new contaminants that are being identified as sort of being of concern. So there is an ongoing responsibility on anybody who implements such a solution, that you have to keep track of what's happening in the world of science. Just as a last bit, what is the impact of this plant? How important is it to us as a city council? What you can see here is the water demand forecast that was done in the year 2012-13. And at the current rate, then we were exceeding the available supply that we had. This, what you see here, was an upgrade to the plant, or actually a rectification of a problem we had to try and get more water. But we were exceeding the available supply. And the options that we could identify at that time was long-term. So taking water from the Okavango River, as I said previously, 700 kilometers away, or going for desalination at the coast, which is also about 350 kilometers away, but also more importantly, 2,000 meters lower down at sea level. So these options were not going to be implemented in the foreseeable future, or at least 10 years to develop. So the city developed a water supply strategy, and the core of that was around reuse, both potable and non-potable. And then we hit the drought in 2016. And like what you can see here is, before the drought, we had access to surface water. So 76 or 3/4 of the water that we had came from surface water. We had to replace most of that as the dams nearly ran dry. 2 of the 3 main supply dams actually went dry. So we had to up the DPR, and we had that option to double it at the time to about 30%. So since then, the DPR has been supplying the city with about 1/3, and that's how important it was. The rest was made up from groundwater as a temporary basis. But if we didn't have the DPR option as a supply, we would have definitely had trouble, because there was a limit to what we could supply from the other sources. And the actual surface water went down to just 8%. So I think that's it from my side, Andre. Yeah, I hope it was fast enough and not too fast. Thank you very much.
Thank you very much, Pierre. Personally, I really enjoyed your presentation. Thank you very much for sharing all these interesting facts and figures. I'm sure that everybody in Mozambique has a lot to learn with the examples that you gave. Noor, can you please share your screen for the next presenter? So next we have Mr. Sydney. So we stay in the same region, but we go across the continent to Durban. Mr. Sydney Mr. Sydney is a civil engineer at the Commercial and Business Department of eThekwini Water and Sanitation, where he is mainly responsible for providing technical assistance and project management for the implementation of various PPP projects. He also assists in the implementation of pilot and demonstration projects in the city for research purposes. Sydney is currently working on a number of water reuse projects within the municipality, which includes their remix demonstration plant and the northern and Kwamushu, uh, the wastewater uh, treatment, something water reuse PPP. Sydney is also a founding member for the Water Institution of South Africa's KwaZulu-Natal Water Reuse Division, something that maybe if you're not familiar with eThekwini, Sydney is from Durban, so this is the municipality that serves the city of Durban in northern East South Africa. So thank you very much, Sydney. As far as I know, you can share your screen and start giving your presentation.
Okay, no problem. Just allow to share my screen, please.
Yeah, I believe that you can do that. Yeah, you can do that. It was just that Noor was sharing hers, so now it should.
Okay.
So thank you very much, Sydney, and the floor is yours. Take us to Durban then.
Okay, thank you, Andre. Hello, everyone. My name is Sydney, as Andre has mentioned. It gives me great pleasure for me to introduce eThekwini to you guys and the projects that we're working in. And yeah, so just to give you a brief background of the eThekwini municipality. So the municipality basically governs the city of Durban and the surrounding towns about it. So I'm just going to give you a brief background of the city of Durban. So according to the last census, we have a population of about 3.6 million people. That population tends to increase every year of about 1.5% per annum. And we are a major port destination, as it's one of the largest port destinations in Africa. So it really falls under that region. So in terms of eThekwini water and sanitation, we supply about 963 megaliters a day from 9 treatment works. Those 9 treatment works are owned by our bulk water supplier, which is Ngeni Water, that supplies to us, and then we buy the bulk from the treatment works. So then we reticulate it from our system, and our system has about 14,000 kilometers worth of water mains and a number of reservoirs. So from that 963, we treat about 500 megaliters a day of wastewater from our 27 treatment works. So to give you a perspective in terms of the supply zones for eThekwini, as mentioned, eThekwini purchases its water from Ngeni Water, which is our main bulk supplier. They supply us from 3 main water supply systems. Biggest one being the Ngeni water supply system, which has a number of dams. We quite blessed in this region. We have a number of rivers coming into the region, and this is the important one that I'll be talking about, is the central Ngeni system. The other ones in the north are still being developed. They support smaller towns, including the ones in the south, but the major one is the Ngeni water supply system. So in terms of water demands, like I mentioned, we purchase about 963, but the greater KZN region for that Ngeni supply system, this is the water and supply demand curve for that region, and eThekwini falls under it. And we commissioned a dam in 2014 called the Springdog Dam, to mitigate against shortfalls of water supply. So in the region, we experienced a major drought in 2017, which went for about a year or two into 2018, where we had to do severe water restrictions in the city. We actually had to reduce the amount of water we supply to our residents. We reduced them about 40%. We went to a very aggressive marketing strategy, and we reduced by quite a considerable amount. But however, going into the future, there's quite a shortfall, as you can see in this graph. We're projecting the demands as. So the National Department of Water and Sanitation, they proposed the Smithfield Dam to mitigate against that shortfall. And that feasibility study was completed in around 2012, 2013. The cost of it was quite considerable. It was nearly $2 billion in today's money. So there were budget complications in the national department. So we as eThekwini had to find new sources of water just to mitigate against the shortfalls between now and when the dam is commissioned. And we saw an opportunity in terms of pursuing water reuse in eThekwini, and we require about 200 megaliters of water reuse for us to pursue those projects. So this is the the new water sources that were considered for the eThekwini. I've mentioned the Smithfield Dam, which is on the far left. And Mgeni has also done feasibility studies in Tongat and the south of Durban, the lower desalination plants. Those were completed in around 2014, but the implementation for us as a city was too expensive because those two plants, the yearly cost was a bit too much for us to operate those two plants. So we chose reuse as our future, as a mitigation measure, as I mentioned in the past. And the three projects that we're pursuing at the moment, well, these are three main projects. It's the reuse in the north, and the remix water in the central parts of Durban, and the Durban water recycling plant, which is the existing plant that supplies treated effluent to industries in the area. So I'll briefly talk about these three main projects and our smaller project as well as support. And the first one was the Northern Works water reuse plant, as we were going for PPP feasibility study. This plant is located in the north of Durban, and we treat about 70 megaliters of wastewater in this treatment works. And we envisage that we will treat the effluent and also supply industry in the area. As you can see that NCP Alcohols is one of the industry players that are interested in taking the effluent, and some of the golf courses and all those things. So the interesting part of this project as well is we also considering direct potable reuse in this area as well. However, this project started in around 2014 as well, but we had resistance from the public, particularly this area, for religious reasons. They didn't want to drink the water reuse water. For religious reasons, and there was no public trust for municipality undertaking such a project. But that sentiment has since changed when the drought hit, right? Because we saw it in our other projects when we go into the public participation, where they were actually encouraging the city for us to pursue this project because they were like, hey, look, there's water shortage in the city and we need to do something about it. So it's either no water or some water. So the idea of water reuse was supported going forward. So our other projects was the Kwamashu Treatment Works. It's also slightly north of that project that I spoke about. That will tie into our existing Northern Aqueduct, which supplies residents in the city of Durban. But before we proceed with that bigger project, we sort of thought about let's pilot water reuse to get more support from the public, from the politicians as well, for us to do these things, because it's very important to prove the concept to the public that, look, it's safe to drink, here are the results. And yeah, so we partnered with the Durban University of Technology in this to test some of the water, and CSIR as well. So they'll be testing the effluent produced from this pilot plant at Kwamashu Treatment Works. So to test reuse and a new wastewater treatment system, which is called MABR, which is sort of an innovative one. But that's a presentation on its own thing. So the other one that we were pursuing was stormwater and effluent reuse at our Mbela treatment works. So this is still at a feasibility study where there's a number of options where we can inject directly back into the aquifer, or we can direct that effluent to a water treatment plant nearby. So that's still in the pre-feasibility stage. We pursuing this as a PPP project, and that requires a PPP feasibility study to be done. So as Andre mentioned in my introduction earlier, we have an existing plant called the Durban Water Recycling Plant. It was our first water reuse plant in the city of Durban, which treats about 47.5 megaliters a day of treated effluent. And this plant was commissioned in 2001. So the main purpose of that plant was to supply industries in the south of Durban. So this was the old Durban International Airport, and the industries were nearby. So it was located at our southern treatment works, which is our biggest wastewater treatment works with a capacity of 230 megaliters a day. And Veolia was actually appointed as a concessionaire to operate this plant. And we mainly supplied Mondi, which is a paper manufacturing company, and Saprev, which is an oil refinery. And yeah, it was pretty successful. There was no major outages. The water supply was great. So we managed to supply 97% of the time to the industries, because we have a backup just in case we can't supply them with treated effluents, where they would tap off potable water from our normal mains. So 97% of the time, we managed to supply them with water. So it was a great benefit for the industries in the south of Durban, because they were paying a much more attractive water tariff, because obviously they are water intensive industries in the south. So they were paying about 6 rand, which is about half a cent of US dollars. So yeah, so it's quite attractive to them to take this water. So like I said, in the past, we did consider desalination, but the challenges for us to pursue with desalination was the high electricity consumption and the brine discharge as well, because there were concerns about the impacts of us discharging the high saline water back into the receiving water. So that was a concern in the past, but the main one was the electricity consumption, because I'm sure you know that the South Africa is having an energy crisis at the moment, and for us to plug in desalination plants will just worsen the situation. So we couldn't really pursue desalination because of those reasons, and obviously the OPEX was a bit too high for us as a city. So we were approached by Japanese government for us to implement a form of desalination. It's basically a mixture of treated sewage and desalination, where we will take rejects from the BWRO, which is the brackish reverse osmosis, and we'll actually dilute the seawater. I'm just going to quickly describe this PFD. So it's mainly a membrane-based plant. So we obviously have a treatment plant that was supplied to the UF and the BWRO membranes. And then desalination is basically a normal desalination plant that's membrane-based. So obviously we have seawater intake to the UF, and then the dilution from the BWRO would dilute that seawater to reduce the salinity in the sea. And by doing that, you're reducing the osmotic pressure. So your pressure pumps are spec lower, And because of the dilution effect as well, the brine that you take out as well, it's about the same as you intaking. So the attractive thing about this technology is the power consumption is quite considerably lower than normal desalination plants, and because about desalination is about 3.8 kilowatts hour per cubic meter. With this technology, maximum yield that you'll be seeing is about 2.6. So this project was brought to us in about 2013. It was introduced to the city. And in 2016, we signed an MOU with NIDO, which is the public organization of the Japanese government, for them to fund a demonstration plant in the city of Durban to prove the concept of the technology. So that was signed then. Basically, it was for us to construct a 6.25 megaliter plant in the city of Durban, and for us to demonstrate it for a period of 24 months and to see if the technology is attractive, and the water quality produced as well is actually great for us. So NIDO then appointed Hitachi to pursue this project, and there was like a 3-party agreement that was signed. And these were the companies that were involved in the project. So just a quick description of the site. This is the port entrance of the harbor that it's in the city of Durban. And this is Central Wastewater Treatment Works, which is the main demonstration site for this project. So we couldn't abstract the seawater directly from the treatment plant because of the wave action. It was going to be more expensive for us to build a protective infrastructure for the abstraction. So we chose the calmer waters of the harbor entrance, where it's protected by the pier, the South Pier. So we can be able to abstract for cheaper. And the harbor as well actually has great water quality. I know City of Cape Town in the past, they tried to implement desalination in the harbor as well. And there were issues in terms of fuel oils from the ships, contaminants that can be laying in the harbor. But CSR actually monitored the water quality for a period of 2 years. And we saw that it's great. And we actually eliminated one of the units in the demonstration plants, which is the DEF air flotation units. So this is the design of the plant. It has an MBR component to it for us to treat the sewage. And all the membranes are housed in this building as well. So in terms of the project timeline, the plant was fully commissioned in about February 2020. But because of COVID relations, we actually had to shut down the plant for quite a number of months because South Africa entered into severe lockdown restrictions, so we had to leave the site. However, the plant is busy being recommissioned at the moment. It should be fully commissioned in a month's time, and they will actually proceed with that demonstration period with the new revised timelines. So part of the larger projects that we're looking at is the standards for water reuse. I'm sure, like my previous speaker has mentioned, there's new emerging contaminants that are being found in our catchments. And then how do we detect and mitigate against those risks posed by those contaminants, like pharmaceuticals and viruses and pathogens that are present in the wastewater, and how do we remove them? So that's when we partnered again with DUT and CSR, who actually is assisting us currently with monitoring our catchments in the area. So all of those different treatment works have different catchments and hospitals and everything feeding into those treatment plants. And we're actually monitoring the levels of these CACs in the wastewater, so that when some of our treatment plants are online, then we can actually see the removal efficiency of those technologies, because it's different technologies on different sites. And part of that study is also to revise the water quality standards that we will be doing ourselves, because the South African standards at the moment, they don't take into account water reuse. It's basically just raw water, freshwater abstraction, and that's about it. So it doesn't look at in details the emerging contaminants of concern. So part of it is just to develop that new guideline for us to implement properly in our projects, and hopefully at national level will be considered as well. So yeah, I think that wraps up my presentation. I think questions will take it in. Thanks.
Thank you so much, Sydney. It is my feeling that at least the southern Mozambique, or Maputo at least, has a lot to. It's not exactly Windhoek and it's not exactly Durban, but it has a lot to learn from both cases. We will go to the last presentation of the day. Noor, can you please put up the presentation slide for Mr. Faisal? Okay, we can also go directly to Mr. Faisal's presentation. So I'm sorry, but I don't have here at hand my bio notes. I do know that Mr. Faisal is an expert at the Food and Agriculture Organization of the United Nations, and he will tell us a lot about the challenges and experiences with water reuse in Northern African countries. Dr. Faisal, thank you very much for joining, and the floor is yours.
Thank you, Andre. Do you hear me?
Yes, we hear you perfectly.
Okay.
And we also see you perfectly.
Okay. Thank you very much, Andre, for the introduction. I will also thank you for the organizer giving me this opportunity to share with you some experiences in North African countries. I will focus mainly on the screen is not moving.
You can share your screen, but we don't see your screen. We just see your camera.
Ah, okay.
I don't think that you are sharing your screen at the moment.
Oh, sorry. I tried to do it, but you give me the opportunity to share it.
Yes, you are co-host, so it should be possible. Actually, I saw your screen. I saw you sharing your screen just earlier, I believe. Or
I can also share, Andre. I have it.
No, you are not sharing your screen,
No,
right?
not now, but I can share it if you want. I have it in hand.
But it's all right. Dr.
Yes.
Faisal, it should be possible. It should be possible for. Oh yes, now we see it. Now it's.
Oh, it's okay.
Yeah, now we can see it. If you just make it full screen.
Yeah. Okay.
Yeah,
okay?
that's perfect
okay.
now.
Sorry
Yes,
for that.
that's perfect. No, that's fine.
Okay, so I will talk about the experiences and challenges for 5 North African countries. We are focusing on these countries because my FAO office for North Africa is focusing on these 5 countries, Mauritania, Morocco, Algeria, Tunisia, and Libya. So I will give you some a picture of all this region of North Africa. But first of all, let me give you a rapid idea about the context, water context of these countries. You know, when you have a total internal renewable water resources less than 1,000 cubic meter per inhabitant per year, so we can have a country with a chronic water scarcity, which is the case of Morocco. For the other 4 countries, Mauritania, Libya, Tunisia, and Algeria, this rate is below than 500 cubic meter per inhabitant per year. So these countries are characterized by absolute water scarcity. So this gives us the conclusion that water security in these countries will largely depend on the development of non-conventional water resources, mainly the treated wastewater. And all these non-conventional water resources, they offer different potentials and challenges. I will focus more on the challenges, because to have these, to improve or to promote the reuse of treated wastewater in this country, we should face the following challenges or constraints. The first challenge is economic and investment. In these countries, there are insufficient investments and a weak institutional capacity in these countries. Also, for the reuse of treated wastewater in agriculture, the price of these resources do not reflect the real economic value and the investment costs. For the incentive also, they have never been able to improve the rates of reuse. You will see when we talk about the potential, how is the rate, is very, very low rate for reuse of these non-conventional water resources. All the funding models in these countries are based on combination of user fees and subsidized from government that do not consider the cost of environmental and health mitigation. Let's see now the political aspects, which is the challenge number 2. And in these countries, national water policy not really address water scarcity, and the integration of non-conventional water resources is not really taken into consideration, and is not included in the integrated water resource management approach. About the legislation also, there are no appropriate legislative frameworks to institutionalize the use of treated wastewater in a comprehensive manner. In particular, there are some regulatory frameworks and guidelines, but it's not enough to promote the use of treated wastewater in these countries. About institutional aspects, we have a multiplicity of national administration and institutions. They are involving in the use of non-conventional water, and sometimes we have contradictory objectives and overlapping responsibilities. This is an important issue in these countries. In addition to that, the lack of communication between these national administration create a lot of problems, and mainly for the promotion of the reuse. There are also the involvement of the end users that are the farmers is generally absent. The implication of farmers is usually not taken into consideration. And another important point that the cost-benefit analysis of these projects are not really taken into consideration, and that's why it is required to focus more on the analysis of cost and the benefits from these projects of reuse of non-conventional water. Let's see now the environmental aspects. These aspects are generally neglected and not really taken into consideration. Environmental and health impacts associated to the risks for the reuse of treated wastewater. When we talk here about non-conventional water, we focus more on treated wastewater. Technical aspects, there are an important need to strengthen the technical aspects related to programming, planning, management, financing, implementation, and operation of these projects for non-conventional water reuse. Finally, the acceptance, the social aspects, the acceptance of and participation of users, we think that are the pillars of the social dimension, are often neglected in all the North African countries, and this is very important for the sustainability of all the projects that using non-conventional water. There is another issue that related to investment decisions that are mainly made by national institutions without proper assessment and consultation with the end users, and this is very, very important for the sustainability of these projects. Let's see now just a quick idea about the potential, the quantities, and the rate of the reuse to give you an idea about the potential of treated wastewater. Let's see the population connected to sanitation system to have an idea about the important potential of quantity of treated wastewater. So we have an important gap between these countries. We see Mauritania, for example, there is no connection to sanitation system, and for the other countries, we are around more than 80% at urban level. And at rural level, the gap is also very important. Let's see now the volume of wastewater collected and treated by level of treatment. We have here around 2.4 billion cubic meter of collected wastewater, and as secondary treatment we have around 30%, and around 5 to 6% at tertiary treatment. For the reuse, we have at the region level, we are using only less than 10%, which is a very, very low rate of reuse. Let's see some example of, quickly some example from these countries. For example, in Tunisia, the reuse is, of treated wastewater is mainly for agricultural irrigation, using irrigating fruit trees, forage crops and cereals. We have golf course irrigation, landscape irrigation in urban areas, and some research and experiences for ground water recharge. Actually around 3,000 hectares are irrigated, and the potential, the estimated potential is 4,000 hectares. So you see really what is, why the rate of reuse is very, very low. Let's see now for Algeria. There are several examples of reuse, and we have different, you know, when the problem is that all these, the existing treatment plants are now under rehabilitation, and they are planning that to have a volume for irrigation around 700 million cubic meter per year, which is very important as potential for Algeria. Let's see for Morocco also, the situation is a little bit mixed between the blocking and the attempting to start, because now the country, they are in Morocco, they are more focused on the indirect reuse of treated wastewater for example, for golf courses and green spaces, and a lot of quantity of water are mobilized for an important more than 1,000 hectares, but these resources are not used. The crop irrigated with treated wastewater, mainly cereals, fodder crops, olive trees, cereals, and alfalfa, but now only the landscape and golf are irrigated. But they have a very important successful story that I want to share with you. This is the project, public-private partnership project, which is in Marrakesh, and this project is really a success story. The objective of this project is protection of the environment, development of urban touristic area, and to cope with the water scarcity. And this project is mobilizing very important potential of water resources. And the idea is the participation of the public sector. And here you see the participation of the government, 12%, and the private sector, 40%. And the state board of Marrakesh, it's a local administration. They participate in this project, which is giving really a very important solution for the promotion of the reuse of treated wastewater. Let's see, in Libya there are several projects of reuse throughout the country, but I will not go in detail on that. The problem in Libya that the reuse is not new, but the problem is the security situation that is, we are not really sure that these projects are still operating. But there are very important projects and with a very important infrastructure and important area with an important potential of quantity of treated wastewater. Mauritania is there is no since 2006 they decided to stop all the production activity in Nouakchott, and but I think now they launched an important study to develop a strategy and action plan to save the situation and to promote the reuse of these potential of treated wastewater in agriculture. Now I just presented the context and the challenges and the constraints to promote the reuse of treated wastewater. FAO, regarding this context, FAO launched a project, a regional project in these countries to unlock the potential of reuse of treated wastewater and drainage water. We focused mainly on treated wastewater and drainage water as two kinds of non-conventional water. And the main objective of this project is to improve knowledge and information on the safe and sustainable reuse of treated wastewater and drainage water for agriculture development. Quickly, I would like to share with you the FAO approach, what we did and what we implement in this region. The idea is, the objective is to improve the reuse and to promote the reuse of these resources of water. So these are the 5 pillars of the approach. That we start with the diagnostic and analysis, the state of the art, and the regional assessments. We developed an ambitious investment program to develop the reuse of treated wastewater through pilot projects. We call them for excellency, because these projects are mainly existing projects, but we developed improvement plans and with a high technology from the collection, treatment, and reuse. And all these pilot sites, these pilot projects, will be interconnected, and we are planning to create a non-conventional water platform for the North African countries. The third pillar is, as I said earlier, that the cost-benefit analysis of these projects is really very, very important, because it gives us the possibility to compare and evaluate different options and to select the optimal and the best one for the investment plan. So we try to have this approach, and we try to integrate all the aspects, technical, social, political, institutional, environmental, and investment aspects. Why I put investment in capital? Because it's really very important now to focus on this challenge linked and related to investment aspects. Finally, this approach reached a policy dialogue between all these countries, and to have this platform, the North African country platform, specialized on non-conventional water reuse. Just to give you an information that we launched in this subject. We launched since last September a webinar series related to how to unlock the potential of treated wastewater reuse and drainage water reuse. This is what I have to say. You know, these countries are now, they should take an important decision and put all the needed support to promote investments in the field of the reuse. Mainly for us, it's very important to contribute to the SDGs, SDGs 6.3 especially. Thank you very much for your attention. Over to you.
Thank you very much, Dr. Faisal. It was a pleasure listening to you. I would like to say that we have three very different stories here. They show different countries in different regions at different levels of development and implementation of water reuse strategies and practices for assuming an integrated urban water management approach. And I'm sure that our colleagues in Maputo have a lot to learn from all the presentations. Noor, could you please, yes, share your screen and maybe the last slide. We now we move on to our Q&A session. There were already a few questions. Noor, could you please have full screen? If you just, at the bottom, you have the icon next to the 60% there at the bottom. The one left to the, yes, that one. Yeah, if you just press it. Yeah, that one, if you just press. Doesn't do anything? Okay, doesn't matter. Let's move to the Q&A session. Okay, Dr. Faisal has to leave. There was indeed a question for him, but we will forward the questions at a later stage, or maybe Selma can ask the question herself by email. We have a few questions for Pierre. Pierre, Mr. Anibal would like to understand. I do know that you talked about this a bit, but he's interested in understanding how you convince the people to accept that the water from the water reclamation or the direct water reuse project was as safe as conventional sources. And maybe then you can talk a bit about the regulatory mechanisms for water use. Maybe I believe that maybe Mr. Anibal wants to hear about the guidelines or testing protocols. I don't know if you can maybe expand a bit on that.
Thank you, Andre. As for convincing the people, I was obviously not around in the 1960s, unfortunately. So I can't give you any direct feedback on that. But as I said at the time, and from all the documents that I studied, it clearly was a situation of, first of all, there was no other viable alternative. So either you have no water or you take this as an alternative. And the other big driving factor, I think maybe more from a government point of view, was the fact that economically this was the best solution. I think they looked at the cost of building big dams and the recovery potential, and it's clear from the economic analysis that was done at the time that really from a cost perspective that this is the best option. Yeah, also, like I said in the presentation, you know, the kind of public consultation that was done at the time is surely not what you would expect today. I think people were less organized in those days. It's not like you went onto Facebook and put out a comment, and within a matter of minutes or hours, you have 100,000 people commenting on the same topic. You know, it wasn't like that. So yeah, it was a very different environment, and I think in a way that made it very much easier for the authorities at the time to put forward the solution. And as I said, they also were very hesitant. You can see from the government documents and the meetings that the issue of public acceptance actually came up quite a bit. The fact that they only had the public launch of the project a month after, and when they saw that, you know, it's probably going okay, we didn't have a rush of people to the hospitals and the doctors. So, yeah, I think it was a brave step by them in a way, but I think it was also a bit cowardice in a way that they approached the public. You know, they definitely did not go with the intention of full disclosure. Nowadays, as I said, people are very much more informed. People can Google stuff. You know, they see a lot when they are on the internet and other sources, so they know a lot more. And the questions that you get are very different. I can maybe just mention that in the last year or so, since we had COVID and the COVID pandemic, a lot of questions came up as to, you know, what happens to viruses and bacteria that could make you ill. You know, if that water comes from a hospital or from somebody's house who does have the virus, you know, at what point do you take it out? At what point is that virus actually removed from the water before you give it back to us to drink? So we had just concluded some research work in that regard, which actually didn't deal specifically with COVID virus, but with actually these antibiotic-resistant bacteria and viruses, which is called these hospital superbugs, the ones that you don't kill with modern medicine. And yeah, the outcome was pretty positive for us. We found that they are destabilized and removed in the process, but I mean, it could have been otherwise. So I think that's why I made the point to say that you really need to stay in touch with what's happening in the world. It's not just a matter of putting the solution there and then turning your back and say, okay, now the people have X thousand of X or X million cubic meters of water to drink, and they must be happy with that. And you need to really keep track of what's happening in the world, because those questions will come your way. And if you don't have a proper answer ready, or you cannot convince the public, you will lose them. You know, you will lose them very easily. And once that trust is gone, it's not a trust that was established over a few months or a few days. That's trust that was established over decades, where people, you know, became used to this as a source. As I said, to the point that some people may even forget that it's a source. Lucky for us, we have frequent droughts in this region. We have one, I would say, on average, every 10 to 15 years, we have a serious drought where we get severely reduction in rainfall, which is highly variable in any case, given the desert environment. And then the question as to where the water comes from really comes up, and it's discussed, and it's widely publicized in the media. And it actually features the fact that we have the reuse plant as a reliable source, and people in a way have become proud of the fact that we have this source that other people don't have, that has been reliably supplying us, and it hasn't failed, you know, when a drought comes around. So I don't know if that answers the question, but that's what I can say to that effect. To come to the second question, Andre, on the standards, you must stop me if I'm talking too much. What we've done, as I've mentioned, we've just gone through a second project, which we are developing at the moment. It's still early days. But there are no clear regional even standards or regulatory provisions that you can fall back on. And I think that's one of the reasons why governments and authorities find it difficult to approve such a solution, you know, because if you go out and you approve it as a politician and something goes wrong, you know, you want that regulatory provision to fall back on and say, you know, I approved it in terms of these regulations, or I approved it in terms of these standards. And those are not so readily available in the world. It is becoming better, with WHO publishing their sort of guideline a few years back. And in the US, they've done a lot of work, especially California. You know, they really went away to try and prove to the public that we have done the scientific bit. It's now just up to you to accept it. So there are standards now. So what we've done is, when we started the project, we really said, you know, water quality do we aim for? Yes, we had this exercise 20 years ago when we constructed the current plant, but a lot has happened in the world in the last 20 years. So we really went out and did a desktop exercise by just accumulating all information in terms of regulatory provisions, guidelines, standards from Australia, from Singapore in the Far East, from the US, from the European community. And we've assimilated all of that, and we said, you know, what would be the strictest standard, the strictest potable standard that we could devise from this, and taking into account that the fact that this water does not come from a natural resource. You have to understand the history of this water as being from a treated wastewater perspective. So we've done that, and from that we have actually compiled what we then set as the goal, the treatment goal. And from there you then design your process to say, but if I want to make that standard consistently, what technology must I employ and how must my process look? So yeah, I'm going to stop there. Thank you, Andre.
Okay, thank you very much. I would extend maybe the same question to Mr. Sydney. Do you see a parallel with the situation? So do you see a parallel between Windhoek and Durban regarding acceptance and at the same time regulations? Is there something different in Durban?
Yeah, in terms of the city of Durban, things are a bit different compared to Namibia. For us, fresh water was seen as the only source of water for the residents. So, like in the past, around 2014, we tried to implement water reuse as a city and in the north. And then we came under heavy rejection from the residents because reuse of water was seen as a dirty source of water. So then that's when public engagement becomes a very important part in this process when implementing reuse projects, because in our remix water public participation process, our first meetings didn't go well because it was like seen as toilet to tap. That was the headlines that were running about in the newspapers. So the perspective changed a bit because we were hit with a drought in around 2017, 2018, where we had to actually implement severe water restrictions for the residences. So then through our public engagements, we were like, look, we need to reduce our water consumptions because of these reasons and whatnot. And the city of Cape Town obviously had national media coverage because their situation was much worse than ours. But ours were very close to Cape Town's situation. So the public starting understanding the different resources of water. So when the Remix project came along, then the public were actually keen in terms of understanding the technologies and how it's operating and everything. So to a point where we actually invite the public to our facilities, to the actual Remix plant to see how it's operated and see the actual water quality that's being produced by such plants. So it's still a challenge when implementing direct potable reuse, but the sentiment is changing, and we can see that when we actually do public engagements for our projects. So we're sort of different from Namibia, but we get in there. Water reuse is not seen as a main source yet, but for instance, for industries, the communities in the south, they very well keen for it being taken by industries, but obviously some industries can't take it because of the involved in food production and etc. So their standards for receiving water is much more stringent than what we actually supply to them. So reuse of water is not part of their strategy. So for us, yeah, so the sentiment is a bit changing at the moment. I hope that answers your question.
Thank you very much. Maybe continuing with you, Mr. Sydney, and I would also ask the same question to both participants again. Actually, we only have 2 more questions. This one comes from Mr. Furmão, and Mr. Furmão from Mozambique. He's trying to understand how do you replicate something like what you have in Durban or what you have in Windhoek in Maputo? And particularly, what should be prioritized for specific conditions? Or in other words, what do you think that worked in Namibia that could also work in Maputo? Maybe you're trying to hypothesize a bit. And what do you think was something that you tried to do that failed that maybe we could learn from? Because in the end, what we are trying to do here is trying to understand. Maputo is still a bit away from implementing this, but we are trying to understand how we will get there. So maybe do you have some ideas for that as an expert?
So yes, from us as eThekwini, the main challenge for us implementing these projects is the public, right? Because that's your main consumer at the end, is the public. So they need to accept this water. So before, when we actually implement these projects, like in the past, we just continued with feasibility studies and designs, and we only consulted with the public at the end stage when they were like, look, we need to build such a plant, there's a technology that's going to be applied, blah, blah, blah. So doing the public participation at the beginning of the project is actually great, because now the public is involved in every step that you're doing. And so that's where we learned our lessons from the past in terms of how do we actually implement these projects, because when you actually construct the plant and the public refuses to take the source, and then it becomes a challenge. So the first thing to do is actually get public buy-in, and public buy-in you're going to only get via if you have political favor to implement these projects. So what we did as city officials is before we actually do this, we actually sensitize the politicians that run the city and actually engage them more, and for them to understand what we're doing, and them to understand why reuse is such an important part of the city of Durban's future, and how do we then sensitize the public in terms of accepting direct portable reuse. So for me, that's the most important part, because once you get over that hurdle, then the implementation becomes easier. Because some technologies are proven, some are not, but if you involve the public and actually tell them the benefits of water reuse and stuff, then they actually accept it. So yeah, it becomes an important one for me. Thanks.
Thank you very much. I'm not sure if Mr. Pierre has something to add, some lessons learned that you would like to share for the case of Maputo.
Yes, Andre, I unfortunately don't know Maputo and the situation there so well. I'll just maybe briefly say that, you know, if you look at reuse as a solution, it's I've said it before. You need to be sure that it's an appropriate solution for the environment, because you can construct the plant and you can get world-class contractors and all the technology in the world, but there is a lifetime of the plant thereafter that you need to consider right in the beginning, because you need to have access to maintenance and parts. For instance, for us and the plant, the actual plant just runs with 3 people there, but we have a whole maintenance team on standby that can come in at any time. You know, they are available at 24 hours, and the plant is actually designed in such a way that if on any of the online measurements something is picked up that shows that the plant might not be performing as it should be, the plant goes into automatic sort of recirculation mode. So it doesn't actually distribute into the network. It just starts to circulate the water from the bottom back to the top until the maintenance personnel can get a chance to go out there. But I mean, that period has to be short, because you can't cut off your supply for too long. This is an important part of the city supply. And you don't really have reservoirs as big to take up the slack and the downtime in the plant. So you need to have access to maintenance. You need to have access to skilled personnel. Obviously, you can train people. When we started the plant, we had a full European crew, and within 1 year, half of them left, and after 3 years, none of them were there. So it's possible to train people, but you need to keep up the skills of those people, because people leave their employment and they go somewhere else. The monitoring I've mentioned, it's very, very important. You have to have access to monitoring facilities, to laboratories, to skilled people in that sense. The research I've already mentioned that you need to keep up in order for you to be able to maintain public trust. So all of that is important if you consider reuse as a solution. So don't just look at the cost of the plant and the technology, but also look at the lifespan or the lifetime of the plant and what you need to actually cover that. So that's one point that I would say is very important. Something we did in the beginning is we had the cost of the water produced by the plant. And I think that's something that we have generally in the region, definitely in South Africa, I've seen this, is that the actual cost of supplying water is not recovered from the user. It's heavily subsidized. So what you pay per cubic meter of water is not what it costs the actual government, the actual investment. Sometimes the investment has just been done a long time ago, that the calculations are not current. But when we put the plant and we try to recover the cost was actually more than what was supplied from the government scheme. So we had times when the plant was shut down because of cost reasons. You know, the water was more expensive, but that luckily changed very quickly. I think within 5 or 6 years we were cheaper and we became more competitive. But be aware of that fact that people will only buy the cheapest water, so you might not have a buyer at the end of the day. So yeah, I think I will stop there. I think there's more to say, but that's it for now. Thank you, Andre.
Right. Thank you very much. So we are approaching the list of questions. We have quite a big one, or quite a long one, from our colleague Adriano. So he asks this for Namibia, but I would also extend the question for both locations, because in the end he also mentions eThekwini. So he says that in Namibia, the direct potable reuse started in the 60s in a society that was highly racialized. Apartheid was an official policy, which meant that the priority of water supply and sanitation services was for the white populations, which was seen as deserving more than non-white communities. This situation was similar for the case of Maputo, and also probably for the case of Durban. So what Adriano is asking, in your opinion, how have these projects addressed or reversed these historical built differences or inequalities in the provision of service? I don't know who wants to go first.
Yeah, okay, it's a very interesting question. Andre, I'll go first if it's okay with Sydney. I think what I can say about this is that if you look at the spatial distribution of people, surely the racial or the apartheid era had a very clear and distinctive effect. Because even up to the present day in Windhoek, you find people of color being segregated majority. I mean, there has been a lot of integration in the last 30 years since independence, but still you find poorer sections of the community, which is predominantly of a certain ethnic origin in certain areas. And that's a legacy of the apartheid. But if you look at water, and specifically water supply, there are two aspects that I think you need to consider. The one is the service that you get, or the service level, and the other one is the source. On the service level, surely, at the time in the 1960s and even for a long time thereafter, the service level that a person of color had access to versus a white person was different. You know, a white person would have had access to piped water into his house, while a person of color might have had a standpipe 100 or 200 meters away. But at the end of the day, the source of the water was the same. You know, regardless of what your access to that water is, the service, the source was the same. And if you draw that back to today, we are very, very aware of the fact that we can't give certain parts of the city a certain type of water and others a different type, because immediately you might be called out and say that you are creating an inequality. Why does the people in the north, the south, the east of the city have to drink treated wastewater while the other people get access to what can be perceived as clean dam water or clean surface water? So what we do is we actually have a central mixing station in the heart of Windhoek. We actually call it the heart of Windhoek. It's a big pump station. And there we blend to the ratios that I've mentioned, the 1/3 to 2/3, and everybody gets the same water. regardless of which part of town you live, whether you're in the old sort of northwestern areas, which was before the people of color, or whether you're in the south and southeastern areas, you get exactly the same mix and access to the same water. And I think that puts forward the point of source. If you control your source as being constant and equal to everyone, you shouldn't have a problem. Thank you, Andre.
Thank you very much, Pierre. That was a very clear question. Sydney, I don't know if you want to add something on the side of Vetequini.
Yes, that's an interesting question. So for us as a city, we have a bit of history because when we entered into democracy in '94, city of Durban had to actually incorporate a lot more areas into the municipality. Because in the past, the white government only focused obviously on white people and areas, and some areas were excluded in terms of infrastructure rollouts. So when we entered into democracy in '94, the city of Durban actually went aggressively to roll out infrastructure in the less privileged areas in the past, and we were the first municipality to actually provide free basic water. So we supply about 6 kiloliters a day of free basic water into the non-privileged areas. That policy has been also taken up by national government as well. So that was in the past. So these projects actually are assisting us into the rollout of infrastructure, because the spatial planning of the apartheid era obviously has not ended. We still have large segregated communities, and we need to supply them with water. Like my colleague from Namibia has mentioned, we had different service levels of infrastructure, of water provision. It's the same with us. Some communities didn't have water, borne sanitation, that's standpipes where about 200 people will share one tap or something. So we went aggressively in terms of rolling out infrastructure in those places. So at the moment, the areas that were previously disadvantaged are actually changing. So the levels of water provision we supply to them also has to change. We need to supply every house with full pressure of water and waterborne sanitation. So these projects, obviously, when we do that, it's more demand on our existing water resources than for us pursuing this water reuse project, she assists us in providing those areas with water. So we're still rolling out. Our peri-urban areas are growing largely, they're getting more urbanized. So these projects actually are assisting us in terms of rolling out our services to our residences. Thanks.
Thank you so much. So Adriano is also thanking for the both answers. On my side, I don't have any more questions, and I think that we addressed all of the questions posed by the participants. I will just have a few closing words. I would like to thank very much all the participants today, Pierre, Sydney, and Faisal, for taking their time to be here today and for sharing their knowledge in the water reuse projects. I think that we all learned a lot with all examples, and that there's a lot to be learned from this. I would also like, this is the last of our webinar, so I would also like to thank all my colleagues, both at Aquashare and at TU Delft, and all my PhD colleagues who participated in the webinars and helped me, for example, in managing the presentation today. Thanks, everybody. On my side, that is everything. We will upload the video to YouTube, and we will share the presentations on our website. I'm not sure if Luke wants to have a few words, or if Mr. Bentumologia wants to have a few words, or if we can just close the session.
Yeah, maybe I can say something. I liked the presentations very much. Yeah, you hear me?
Yes.
Yeah. Okay.
Yes.
Yeah, I like the presentations very much, and I think yeah, there's a lot to learn. And yeah, also my questions were how we can translate the experiences from the different countries towards Mozambique. But I think also with water scarcity is, I think, a very big driving force. And yeah, Mozambique is facing this water scarcity too, and alternatives of building big dams that are, yeah, you can look into that. But yeah, the wastewater is much nearer and also fresh. So I think, yeah, there's a lot to learn from Mozambique to see how this could be included in yeah, urban water management.
Thank you very much, Luke. So I think that from my side we can finish for today, and thank you everybody for participating.
Okay, thank you very much.
Have a nice day. Thanks everybody.
Okay, bye bye.
Bye bye.
Bye bye.